Great. So thanks for the introduction, Jason. And as you mentioned, this presentation is going to be split into 3 parts. So I will be talking about urban climate services first, and then Lizzie Kendon will talk about urban climate change and the science, and Lucy Villarkin from Bristol City Council will give the user response. So I'm briefly going to discuss why we need urban climate services, how we create them, what we're currently developing, and some of our future plans. So there are many reasons to develop urban climate services, and as can be seen from the diagram on the right, cities are extremely complex and interconnected systems with vastly varying degrees of risk, resilience, and vulnerability. And this makes them particularly vulnerable to the effects of climate change, which can often be amplified within the city compared to the surrounding countryside. One example of this is the urban heat island effect, where temperatures within the city can be significantly higher than the surrounding areas, particularly at night. There are also some financial consequences of climate change, and these can have a considerable impact. For example, unexpected expenditures from storms and flooding can lead to major disruptions in business operations and city budgets. And finally, urban growth shows no signs of slowing down. So when we create urban climate services, I find there are 2 real key components. The first of this is pull-through of underpinning and emerging science. So as mentioned in the last slide, the urban area is very complex, and we are only just getting to grips with its many complex interactions and physical processes. So as new models and methodologies, science and data become available, it's essential for us to not only understand how to best use this science and information, but also the value it can add and its limitations in order to inform effective services. So as part of our ongoing service development within the SPF programme, we work very closely with the underpinning science work packages, such as Lizzie's, to make the best use of this new information within our service development. And the second key component is that the service is co-produced and co-developed with the decision maker. So what is co-production? So there are many various definitions of co-production. And one that I quite like is that it's a shift from the one-way push of scientific information to a 2-way collaborative process of knowledge sharing and knowledge construction and sharing. The one-way push is often seen as quick and easy, while the 2-way collaborative process is often more time-intensive, more resource-intensive, and more complicated. So why do we want to invest time and resource into a more complicated process of service development? Well, firstly, I want to produce a service that not only presents climate information in a way that's understandable and interpretable, but also in a way that's relevant to the decisions that need to be made. And the only way I can achieve this is to engage directly with the decision maker throughout the whole process. Secondly, the information that I provide is often only one component of the information that the decision maker needs to consider in order to make their decision. So for me to provide the most effective information, I need to engage with all the actors within the decision-making process, and co-production enables this. And finally, I want my service to be sustainable. I would like what we develop to be useful beyond the lifetime of the project. And to achieve this, the decision maker needs to understand the information and have ownership of the service. And co-production, again, is an effective way of achieving this. So this is work that I carried out with Catherine Vincent and Megan Daly a few years ago, and describes a general approach to co-production, which we take when we're developing some services. The left column describes how the process should be. So it should be inclusive, collaborative, and flexible. The right column describes how the service itself should be characterized. So the service should be decision-driven, process-based, and time-managed. And finally, the center identifies some of the steps which could form part of the process, and all this is wrapped in a bubble of continuous monitoring and evaluation. Now, I know there's no one-size-fits-all approach to co-production, but I found that applying such a general approach definitely helps to frame and define a suitable way forward for any given scenario. And finally, I think something that needs to be carefully considered in any approach is the time effort required, which is often greatly underestimated, especially at the very beginning, when time is needed for relationship building. So now I'm briefly going to go through some of the services that we're currently developing as part of the SPF programme, starting with the City Pack. So we developed our original City Pack with Bristol City Council, and these are high-level, non-technical summaries of climate change projections for Bristol City. We started engaging with them over 3 years ago now, and it took quite some time to define the council's requirements, but working together we found that what was most important for them at the time was to build a collective understanding of future climate change for Bristol City within the council itself, and to communicate uncertainty in the climate projections in a clear and simple way. So we followed a co-production approach similar to what I've just described, and on the right you'll see an outline of this. There were 4 main steps. Step 1, to engage and define. Step 2, to co-develop and co-deliver. Step 3, to co-deliver and discuss. And finally, step 4, to review and improve. We also included some intermediary steps along the way. The first intermediary step was to provide some samples of the types of things we could provide based on our initial conversations, and this provided a good starting point from which to evolve from. And we found that this has become more and more important in recent times as everything has moved virtual and we're not able to do the face-to-face workshops, which we would normally have within a co-production process. We also included some specific evaluation steps, to be precise. The first was to evaluate how well the service meets Bristol City's needs prior to finalisation. So, for example, does the service need any last-minute adjustments before delivery? And the second, which is really important, had 2 aspects. The first was to understand whether the service delivered what Bristol required once they had a chance to put it into action. And the second is to understand how useful the service could be to other cities, and this is work that's currently ongoing. On the left of this slide, you will see an infographic of the City Pack life cycle, and this will be published on the SPF webpage shortly and gives some details of the process that we took in developing them. So this is what the City Pack looks like. It comprises of 3 fact sheets and includes information on the science, the results, and the results explained. It's based on the 25-kilometre UKCP climate projections for all scenarios, and provides some headline messages and city-specific information on how hazards such as heat, rainfall and sea level rise could change into the future across different scenarios. And here Bristol City chose RCP 4.5 and RCP 8.5 as their scenarios. It also included some additional information such as information on the weather for the city, how the climate has changed for the city, information on how we model future climate, and information on the different emission scenarios. And if anyone wants to see these in more detail, they're all published on the SPF webpage, or you can contact me as well. So I won't focus too much on the feedback because Lucy is going to go into this in a bit more detail, but initial feedback received from Bristol City Council was very positive, and they were used to inform their One City climate strategy, which was great. So what next for the City Packs? Well, to date, we've been contacted by multiple cities across the UK to reproduce these, and we've done so far for Belfast, London City, Leeds, Glasgow and Exeter, and there's a few more in the pipeline for Newry, Hull, I think Barnsley as well. So we're currently reviewing the City Packs as they currently stand, and we've developed a feedback questionnaire. So we'll be getting feedback from all the other cities on their effectiveness. And this will hopefully inform work in the new year on how to best reproduce these for more cities across the UK. So there are a number of other services that are in development at the moment, focusing on heat and precipitation. And I'll very briefly go through the heat service as this is further along in development. But again, if anyone would like more information on any of the other services we're producing, please do feel free to contact me. So why have we started with heat? Well, heat is one of the 6 priority areas identified in the UK Climate Change Risk Assessment where more action is needed. Recent events have meant that it's become very relevant, and it's moved up the agenda of city governments as an issue that needs to be addressed with urgency. As I mentioned before, cities are very vulnerable to heat, and it's often amplified within the city compared to the surrounding countryside. With the release of the UKCP data, we have a new high-resolution data set available for the UK, which can provide insight at a city scale, which we didn't have previously. There's some exciting new science and understanding emerging around heat, which Lizzie will go through in the next section. And also there is a strong requirement from a number of cities to develop an evidence-based and understanding of current and future hotspots within the cities. So the initial prototype is being developed with Bristol City Council. However, we're also engaging with other cities such as Belfast, Glasgow and London, as different cities have different vulnerabilities to heat. And again, it follows a similar co-production approach as I've already described. The heat service takes a two-tier approach. So tier 1, which is currently being developed, is very similar to the city packs. It contains some high-level city-specific information related to future heat changes. There is heat, it uses heat indices from the ETC-CDI indices, which includes changes in max mean temperature. It includes the number of days exceeding certain temperatures, the number of consecutive nights, of hot nights, and how these change into the future. The heat service itself is created using the UKCP local data. So this is the 2.2 kilometre data from the UKCP data set, which is at RCP 8.5, and it will be very graphical. So not much text and very user friendly. The second level, which is tier 2, is very more specific to the city's particular vulnerability to heat. For example, it will examine heat relationships to health, which is what we're looking at with Bristol City. It could examine heat relationships to the built environment, which is what Belfast City are interested in, or other socioeconomic vulnerabilities identified by the cities. So it requires a lot of user engagement and buy-in from the city to produce these, and it'll be map and GIS based. So hopefully this prototype of the tier 2 should be developed by the end of March. So finally, finishing on some future plans for urban services. In the next year, what we'd like to do is further develop our current offering. We'd like to explore some new services, potentially looking at coastal cities, maybe look at how drought impacts the city or multiple hazards. We'd also like to look at strengthening the decision support interface. So what can we do to further support decision makers in using the climate information that's available? We'd like to identify and address gaps and limitations. So again, this isn't just gaps and limitations within the services themselves, but also within the underpinning science and within the decision support interface for the users. And finally, what we'd like to do is further pull through and drive future science for service development. So on that note, I will pass over to Lizzie.
Hello, thank you. Yes, I'm Lizzie Kendon, and I'm going to be talking more about some work that we've been doing using the UKCP local 2.2 projections, which Claire has already mentioned. So this is primarily work by Will Keaton, my team. So thanks to all the hard work from Will. So for those of you who are not familiar, the UKCP local projections were one of the products released as part of the UK climate projections in 2018. And the latest high resolution results are for 2.2 kilometre resolution across the UK. And they were launched in September 2019. And as the figure shows here, you can really see how much we're able to zoom into a grid box over London. So this is what a 2.2 kilometre grid box looks like compared to a 12 kilometre grid box, which is more traditionally what's used for regional climate projections. And please, can you move on, Claire? So these 2.2 projections actually consist of 12 models. So they're using a model that's as detailed as that typically used for weather forecasting. And this is the first time that we've provided national climate scenarios at this convection permitting scale. It's really important because it allows us to give new estimates of changes in daily and hourly extremes, so storms, summer downpours, severe wind gusts. and we can feed this information directly into impacts models, but also it allows us to really zoom in to climate change over cities, and that's what I'm going to be primarily focusing on today. So we have 12 members. They're driven by the 12-kilometre regional model, and we have data for 3 periods going out into the future, or the high emissions scenario, RCP 8.5. Next slide. So in terms of hot summer days, these local projections show that we might expect hot summer days to warm by about 3.7 to 6.8 degrees C across the UK by 2080 under RCP 8.5. So these hot summer days warm more than the summer average, and they also warm more than cold winter days. Now, if we look at something like spells, for example, exceeding 30 degrees C for 2 or more days, which is a threshold used public health warning, these projections suggest that these will be 16 times more frequent by the 2070s compared to 20 years ago. That's a massive change. Now, these are RCP 8.5. If we follow a lower emissions scenario, then the changes are considerably reduced, approximately halved. And in general, what we find is these local 2.2 projections reinforce the results from the regional 12-kilometre for the UK-wide picture, but they're able to provide a lot more detail locally. Next slide. Now, one thing it's very important to realise is that these 2.2 projections, they're providing some estimate of uncertainty at local scales. They're not providing a full uncertainty range. So the local 2.2 projections only downscale Hadley Centre models, and these are ones that simulate relatively high levels of global warming. So this figure on the right side really illustrates this. So this is looking at responses for Scotland and England by the 2070s for summer temperature, precipitation, winter temperature, and winter precipitation. And it shows a range of changes across all the different models, the different UK CP18 products. And what you can see is that in black is the probabilistic projections, in blue is the CMIP 5 models, in yellow is the Hadley Centre Global model, which are then downscaled to regional 12-kilometre in pink and the 2.2-kilometre in green. And you can see here very much illustrates that in summertime, we're sampling relatively warm and dry outcomes, 2.2-kilometre model. So it's important to bear this in mind when we're looking at these results, and that we're not really sampling the full range of uncertainties here. Next slide. So this is work where we're really now trying to focus on the urban aspect of this. To what extent differences in changes between the 2.2 and kilometre models are really reflecting the different representation of cities, and not just the high resolution, but the different improved process representation as well. So firstly here, I'm just looking at present day hot summer days, and we have the observation on the left, and then we have the 12-kilometre model and the 2.2-kilometre. And what we find is large differences in the representation of urban temperature extremes between the 12-kilometre model and the local model. Particularly here, you can see that hot summer days are warmer in the 2.2-kilometre, in much better agreement with observations. So on the bottom, we show here the biases in the 12-kilometre model compared to the observations. And you can see hot summer days are too cool, as the biases are considerably improved in the 2.2. Next slide. If we move on to warm summer nights, we can now start to really see some urban influence here. On the top left is the observations. We've got the 12-kilometre model, and you can see really warm spots over cities here. And then on the right-hand side is the 2.2-kilometre. And if we look at how these compare in terms of biases with respect to observations, in the RCM night temperatures over cities are far too high. You can see that on the bottom middle panel there, whereas the 2.2 is able to give a much better representation of warmth compared to observations. Next slide. So a key thing here is what try and understand to what extent this is due to the urban influence. Next slide. So we've developed a new methodology to really extract. Oh, can you go back one, please? sorry. Will's developed a new methodology to really extract the urban influence on temperature. And this allows us to understand what's going on in the rural background and the urban signal on top of that. So this is firstly showing results for hot days, summertime. We have the 12-kilometre model on the left-hand side and the 2.2-kilometre model on the right-hand side, both looking at the present and future change. And what we can see is on the bottom, these are the urban signals extracted. And you can see there's a much stronger urban signal in the 12-kilometre model. You can see the features over the cities there compared to the CPM, but then in terms of future changes, this daytime urban heat island seems to decrease in the future. This is potentially related to changes in soil moisture, the effect that we get drying soil in the future. And in that case, they tend to respond more like the city environment, and so the urban heat island itself is seen to decrease. But this is work very much underway at the moment to try and understand this. Interestingly, in the CPM, we see very little change in the daytime urban heat island in future. So that's the bottom right plot, which is quite different to the tendency of almost a decrease in the urban heat island we see in the regional model. Next slide. If we move on now to look at warm nights are particularly important from a public health perspective and giving people a chance to recover from the heat during the day. And what we actually see is that the urban heat island is more pronounced at night time. And again, we see here this much stronger urban signal in the regional model, with the urban heat island seem to increase in the future. So if we look at the bottom plots here, this is looking at the urban signal in the 12-kilometre and 2.2, firstly showing the urban signal in the present day and then the urban signal in the future change. And you can see there's an exacerbation of this urban heat island in the future in the EM. Whereas in the CPM, there's very little change in the nighttime urban heat island in the future. And we think the big differences here in terms of representation of urban heat is down to the different ways the urban environment is represented in the permitting model. So not only a much finer grid spacing, but also we have a scheme which is able to represent roofs and canyons within the urban environment, and that's important for getting the fluxes and the downward evolution of temperature right. Next. So I thought it was useful to see how this actually translates to what we actually see in terms of frequency of exceeding hot days and warm nights in the future. So here we're looking at the top panel here, we're looking at the frequency of hot days for Greater Birmingham and Greater Manchester. And on the bottom, the same, but for warm nights. And so the bars here reflect, firstly, the frequency of these in the present, and then on the right-hand side, and within each panel, the frequency in the future for the 2070s under this RCP 8.5 scenario. And so typically in the present day, the definition of these hot days is such that we would expect typically once every summer. And you can see as we move into the future, the results are 20 or more of these what would be typically a hot day now occurring over the cities in the future. The red is for the convection permitting 2.2-kilometre model, and the blue is for the 12-kilometre regional model. And you can see the light colours are the rural temperatures, and the stronger, bolder colours are the urban results. And there, perhaps less strong than it is for the warm night. So in the warm nights case, we're saying that what we typically describe as a warm night now will be occurring on a third or more of nights in the future. And there's a really strong urban signal in that. But again, we find that the regional model in blue is showing too many of the nights, as you can see, compared to the observations in the bottom. Next slide. So here we're looking at how the urban heat island varies with daily temperature. So, you know, is the urban heat island particularly important for the hottest days or the warmest nights? And how does it vary across the models with the observations? So again, here we're looking at 3 cities, London, Birmingham, and Manchester. The top is for daytime temperatures and the bottom is for nighttime temperatures. And the open symbols here are the observations, the NCIC observations, and then the red colours relate to the permitting model, and black to the 12-kilometre RCM. And what you can see is, as you move across different centiles along the bottom, you can see how the heat highland varies for these different things. And I think the thing that is most striking for these, on the bottom, you can see in black here, the results for the 12-kilometre RCM for the present day, showing this big increase in the urban heat island as we move to higher temperatures. And that's something that isn't in the observation, so black open boxes, that's not something that we see, and indeed isn't seen in the convection permitting model red. And so we're really finding evidence that the RCM is affecting the urban influence, especially for the hottest months. And that seems to be exacerbated in the future. Okay, next slide. So just to finish with some future plans for this work, we're really keen to try and develop more process-based understanding of these differences in the urban heat islands that we've been showing here, because that's critical for really allowing us to assess the reliability of future projections. So some of the key areas that we're going to be looking at is the role of soil moisture in controlling rural background and how that is influencing the urban heat island. And we know that soils are drier in the convection permitting model due to the very different nature of rainfall, which is much more realistic. In turn has an impact on how is warming differently with respect to the rural background. But also we've got a different representation of the urban environment itself in terms of representing roofs and street canyons, and the role of that is also something we really want to be looking at. And this underlying scientific knowledge is important to support the work Claire talked about earlier in terms of the urban climate services and the Bristol heat prototype, because this is really allowing us to assess which UKCP products in particular are most reliable for this type of work. We're also wanting to extend this work to precipitation to really assess the urban influence on convective storms and future changes in hourly rainfall extremes. And this is really important because urban areas are particularly prone to flash flooding. And these new local projections at 2.2 kilometre resolution are really allowing us to look at this sort of thing for the first time. Also, I think really important, we'd like to develop guidance for users in terms of the strengths and limitations of the different UK CP18 products for urban climate services. And we need to want to advise really high resolution projections as needed, but also to really understand the thing I touched on at the start of the talk in terms of the uncertainty context. These local projections aren't sampling the full range of uncertainty. And in cases, it may be important to explore all the many different products to really bring in the wider uncertainty context to the results. To try and help with this, we're wanting to do some downscaling CMIP5 models, 2 kilometre resolution, and also multi-model CPM information emerging from other projects, such as the EUC project. And I think this is really important for allowing us to better sample uncertainty in these changes that then feed into the urban climate services work. And finally, a key area of interest is trying to develop methods to synthesize the information we have from these new convection permitting projections with the larger global model ensembles. So I think many users may struggle with understanding which source of information they should use for their particular area of work. We've got these handfuls of convection projections and then much wider ensembles of global models. I think a key area where I'd be keen that we can develop in the future is actually developing methods to synthesize this information, which I think will be really useful for user applications. And with that, I'll stop there. Thank you.